Hello everybody, this is Math on 40, day 15. We need to talk more about lines, still in that module 6. It's important enough. And we've done the slope-intercept form. We've done the point-slope form for lines. So today I'm talking about a different angle, a different viewpoint. When we look at equations of this form. ax plus by is c. And you can write every line equation in that form. And then when equations of that form come at you, you might be asked, find us the slope-intercept form. Of 4x minus 5y is 7. So basically it means solve it for y. So we add 5y to both sides. And then we subtract 7 from both sides, which gets me to 4x minus 7 is 5y, and then divide by 5. When I'm putting it in the margin, I mean do it to both sides. So what do we get? We get 4 over 5x minus 7 over 5 is y, and I've solved the equation for y, and that is a slope-intercept form. Okay, it's right and left side flipped, but I'm not nitpicky. That is a slope-intercept form. Okay, so that's not hard. What else? Yeah, the question said find the slope. No, sorry, it said find the slope-intercept form, but of course it's now a piece of cake when anybody asks what is the slope of that line. It's the 4 over 5. What is the intercept? It's negative 7 over 5. Did I just write m? Four over 5 is the slope, and the intercept is negative 7 over 5. So you can just read it off the slope-intercept form. That's why it's called slope-intercept form, and that's why it's good. What else can we do? We can talk about x and y intercepts. The y-intercept is the intercept that we've been talking about before. And then there's such a thing as an x-intercept. And that is the x-coordinate of the point when your line intersects the x-axis. Like the y-intercept was the y-coordinate of the point where your line cuts through the y-axis. Well, to find that one, we need to set y equal to 0. and then solve for x. Oh, we can do that. Get 5x minus 7 over 5 is 0. And we multiply by 5, add 7, and then divide by 4. 4x is 7, x is 7 over 4. That's our x-intercept. Notice that we could already have done that with the original implicit equation right up at the beginning. You can set y equal to 0 there and find out what's x going to be, and you find the same answer, 7 over 4. Implicit given equation. I can't help it. I want to draw those points and see what they tell me geometrically. Let's say 7 over 4 is here. X value 7 over 4. It's going to be on the x-axis. And then the y-intercept was negative 7 over 5. So that's somewhere on the y-axis down here in the negative part. Okay. I'm going to write this in. 7 over 4 here, negative 7 over 5 there. And our line passes through both these points. So the line is completely determined by the x and the y-intercepts. So one more example. Given a line with y-intercept 3, x-intercept 2, find me the slope-intercept form of an equation for that line. Oh, sorry, the slope-intercept. For that line. And the answer is that the two intercepts give you 2 points. You start with those 2 points. Namely 0, 3 from the y-intercept and 2, 0 from the x-intercept. And whenever you have 2 points, then the recipe I did in my last pair of videos should enable you to calculate the slope of your line. M is y2 minus y1 divided by x2 minus x1. In our case, that is 0 minus 3 divided by 2 minus 0, which is negative 3 over 2. That's my slope. And then I can go for point slope form if I like. So I use the first point there, 0, 3, and I get y minus 3 is negative the slope times x minus the x1, the 0. And then I got a point slope form. To convert that to slope intercept form, I just add 3. I get y is negative 3 over 2x plus 3, and I'm done. Right, so switching between all these descriptions of lines is fun and profitable. It's useful. It's really useful in many situations. So that's why I'm really beating down on this dead horse. What else do we have about lines? Okay, at some point we got to talk about horizontal and vertical lines. Horizontal. Exactly, if it has an equation y is b, a constant with no x in it. And that, again, is equivalent to, it has slope 0. So in your slope-intercept form, you have to have a slope 0 so that the x is cancelled. It's killed off, doesn't make a difference, whatever x value you have. And then you are left with y is b. That's enough about horizontal lines. A line is vertical exactly if it has an equation x equal to a. You can think about that. You can draw some examples. That's all not hard. It really gives you the vertical lines. And that happens exactly if the slope of it is not defined. It doesn't make sense to talk about the slope of such a line. Don't do it. If you're trying to apply the formula for slopes, you take two arbitrary points on that line, and you've got a denominator x2 minus x1, but the x's would all be the same. They would all be a. So you have a denominator of 0, division by 0, boom. The slope formula does not answer, does not compute, gives you an error. So that takes care of vertical lines. I wrote it in a way so that it should be a mirror image of the horizontal lines. When you flip the roles of x and y, you flip the roles of horizontal and vertical. And I should mention that the horizontal and the vertical lines fit very well into the framework of implicit equations. That is, equations like this: ax plus by is c, right? They fit into that framework, whereas slope-intercept equations cannot ever describe a vertical line. So that's the one advantage that the implicit form has over slope-intercept form, that you can handle really every line in the plane. I give an equation for it in that form. Downside of that implicit form is it takes a bit of work to calculate the slope, and you can have multiple equations for the same line. Just multiply it through by a constant, you got a new equation of the same form, and it gives the same line, but it looks different. So all of these are good. It's just small differences. I mean, each of them has their little advantages and disadvantages. Last bit about lines, parallel and perpendicular. Parallel, of course, if they never meet. And algebraically, how can we tell it from the equations? They both have the same slope. So it's particularly nice to tell when you have the slope-intercept forms for equations. And another possibility is that they're both vertical. We can't talk about slope then, but both slopes are undefined, they're both vertical, and they are also parallel. Fine. Should we do an example? Find an equation for the line through 1, 10, passing through that point, and parallel to, this is how textbooks usually write it, y equal to negative, what was it, 3/2x. What do we do here? Answer, the point slope form is the answer. If it doesn't say slope intercept form, go with the point slope form here. Because you can't just do y minus 10. You grab that y value, put it right here, equal to negative 3/2, the slope, times x minus 1. That is using the x value here, the 1, and subtract it right there. That ensures two things. First, when x is 1, y is 10, so it really passes through that point. You have to have this. When x is 1, y has to be 10 to make that a true equation. And second, the point slope form has that slope sitting right here. And it's negative 3/2, so they have, this line has the same slope as the given one. They're parallel. So you're done. No need for slope-intercept form because nobody said that. And you can just write it down without computing anything. Now the last bit, find an equation for the line through that same point, 1, 10, perpendicular to y is negative 3/2x. And here we need to use one fact. I think I've mentioned it at some point, but didn't do an example. Anyway, the rule is two lines are perpendicular if their slopes multiply to give -1. That means perpendicular if their slopes multiply to -1. That is the breakthrough. That tells you what slope we need for our desired line. The given line has slope -3/2, so the one we want has slope 2/3. Okay, and the point slope form does it again. We go y minus 10 equal, what slope did we want? 2/3 times x minus 1, and it's done. So these questions are just a no-brainer and still very powerful, useful mathematics. But enjoy it while it lasts. Cash in those points. Don't mess them up. That is it for lines.